Hey again, everybody. Mr. Reeves back with you as we continue to look at the area of composite figures, or what IXL calls compound figures. So in the previous video, which I hope you got a chance to watch, we found the area of figures like this that were made up of only rectangles. All right, so those represent the most basic of the compound figures that we're going to find the area of. All right, now we're going to move up to ones like this that actually have triangles in them. All right, so I'm going to go ahead and solve this problem. Again, the idea is the same. No matter what the compound figure is, we want to break it up into parts and then find the area of each of those parts and then add those areas together. And again, as I've said before, you have some choices how you divide up the figure. Sometimes, though, you're not really going to have a choice. For example, down here you can see that we have well, actually you do have a choice because you could make it a trapezoid. All right, but I'm going to go ahead and say let's go ahead and go across here and make a triangle right there. I was saying, right, we could go like that. And if we had done that, this part would be a trapezoid, this part would be a triangle, and you're certainly welcome to do that. But I'm going to go ahead and have this triangle here, and then I'm going to go across here and have a rectangle. So we have a triangle, a rectangle, and a rectangle. Like I've been doing, I'm going to label these 1, 2, and 3. So we're going to have area 1. We're going to have area 2. And we're going to have area 3. Alrighty, area 1, area 2, and area 3. So area 1 is a rectangle, and I hope by now you can do this in your sleep. The area of a rectangle is length times width. We have 5 times 3, and 5 times 3 is 15. Let me change these to equals. 15, and the units are kilometers squared, or square kilometers. All right, area 2 is also a rectangle, length times width, right? All right, so again, it's 7 times what? We talked about this in the last video. All right, sometimes you're going to know very clearly what those lengths are. Like this one was 5 times 3, was easy to see. But right here, I need to know this distance all the way across here, right? I want to go all the way across there. And I know from there to there is 7, but what about from there to there? Well, from there to there is what? It's 3, right? Because it's the same as that, right? So 7 plus 3 all the way across is going to be 10. So this one is 7 times 10, right? 7 times 10, 70 square kilometers. All right, and then now for the trickiest of all. All right, here we go. So we have this triangle here, correct? And we know that the area of a triangle is 1/2 the base times the height, right? So 1/2, and remember the base and the height are always perpendicular, right? So you can see right here, this right here. I'm going to go ahead and call this one the height. And that's going to be 5. And this all the way across here, I'm going to do it in red. That right there is going to be the base. Now again, we run into a little bit of a problem, don't we? Because from there to there is 8. But what about from there to there, right? Well, if we come straight down here, oh darn, it doesn't hit it, does it? So we're going to have to get a little more complicated here. So from there to there is 4, right? From there to there is 4. Do you guys see that? Let me make that a little bit wider. So from there to there is 4, right? And all the way across, do you remember up here? Do you remember what we said that was? All the way across, we said that was 10, correct? So this part here, if that red part all the way across is 10, and I'm going to put it. So 10 goes from there. I'm going to erase these just because. Okay, so make it a little cleaner here. So from there to there is 10. This is really important. From there to there is 10. And from there to there is 4. Wrong color, buddy. Here we go. Let's try this again. From there to there is 4. Oh my goodness. 4. Then what is this part? What's this part right here going to be? Right there. Well, it's going to be 10, take away 4, or 6. Okay, so see how that's kind of tricky, right? You have to know what it's made up of. I thought maybe coming down here would help me, but the problem is it didn't intersect there. You got to be careful, right? But I do know that that entire rectangle length right there is 10 because it was 7 plus 3, right? 7 plus 3, that's what gave us that 10. And then we take away that 4 and we're left with 6. All right, so now I can actually add this one right here. I'm going to add this 8, right? That 8 goes from, let me go ahead and make this part blue too. So now what I'm doing is going from there to there is 8. From there to there is 6, so that entire blue length, that base of that triangle is 14. 14. All righty. Let me just rewrite it. 1/2 of 14 times 5. All right, half of 14 is 7. 7 times 5 is 35, and we get 35 square kilometers. And now we're going to add those together. All right, 15 plus 70 is going to be 85. 85 plus 5 is 90. 90 plus 30 is going to be 120 square kilometers. Or if you wanted to use your calculator because you're doubting your math, 15 plus 70 plus 35. Was Mr. Reeves correct? 120 is correct. All right. And this is always a little scary on these problems, putting the answer in and checking. All right. Woohoo, we got it. Okay. That one was a little bit tough. So we'll see if this one is as well. All right, so here we go. We're going to go ahead and divide this one up. Again, we have some choices. All right, I am seeing a triangle here. I'm wondering if I should do a trapezoid. All right, now you know what? I'm not going to do trapezoids. We're going to stick with the triangles. All right. All right, and then I'm going to go ahead and go over here. Okay, I went curved down, so here we go. I think this one's actually going to be a little bit easier as I look at it. All right, so again, we're going to divide this up into sections. I'm going to do 1, 2, 3. I like to save the triangles for last because they're the most fun, right? So we have area 1, we have area 2, we have area 3. Ka-chow, ka-chow, ka-chow. 1 is a rectangle. Again, rectangle length times width. We have 5 times 4 is 20. 20 what? 20 square inches. Rectangle number 2. All right, 9. Do you see all the way across? 9 times 7. By the way, if we had worked across the bottom, 4 plus 5 would also give us that 9, right? But since we've got it, 9 times 7. So the area, again, is length times width. It's going to be 9 times 7. I hope you know your 9s and your 7s. You get 63 inches squared. All right, and finally the triangle. The area of a triangle is 1/2 base times height. All right, so remember base and height are always perpendicular. So my base is going to be 5. And then the question is, what is my height right here? What is that distance right there? Okay, so again, we have a little bit of an issue to look at. Let's see, if we go straight across from here, let me use a different color and let me make it a little bit wider, shall I? I'm going to go straight across. And the question is, how do we find that height, right? Well, do we know this entire distance? Do we know this entire distance here? And the answer is yes. Can you see that that entire blue segment is that one plus that one together? Yeah? Okay, can you see that? That 7 plus 5 is 12. 7 plus 5 is 12. So the whole thing, that whole blue length is 12. So this whole blue length is 12. You see how that distance from there to there is the same as that distance from there to there. It's just this one is those two put together, right? Okay, well then, but from here to there is what? 9. So 9 plus our height has to equal 12, right? 9 plus our height has to equal the same thing as 5 plus 7, which was 12. Well, that means h is going to be 12, take away 9. And when you do 12, take away 9, you get 3. All right? So that means that h is equal to 3. So that means our triangle is 1/2 of 5 times 3. All right, so half of 5 is 2.5. 2.5 times 3 is 7.5, or we could have done 5 times 3 is 15 and done half that way. Okay, so we have 20 plus 63 plus 7.5 for our total area. Here we go. I'm going to clear this out. I'm going to go 20 plus 63 plus 7.5. And when I do that, I get 90.5. 90.5. All right, drum roll, please. 90.5. Okay, good job. All right, so I'm going to skip up one more level and see what they give us here. Okay, so this will be our last one. I think we're going to do that involve rectangles and triangles. All right, so again, we have different choices on how we choose to do it. And I bet some of you are going, why did you do it that way, Mr. Reeves? I would do it this way. And that's fine. You break it up however is easiest for you. That's a great thing about these problems. Okay, actually, I'm going to go back and make it thinner because I like my first lines to be thinner. So I'm going to go ahead and come across here. And that's going to get me my triangle. I usually do the triangle one first because we don't really have a lot of choices there unless we choose to make a trapezoid. All right, and then I'm going to go across here. Right, no, I'm going to come down here. And then I'm going to come down here. All right, and again, as I'm looking, I'm saying, well, I could have done that, or I could have done that. So again, you break it up how you want to. If you don't like the way I'm doing it. Okay, so here we go. All right, so I'm going to go 1, 2, 3, 4. All right. Area 1. Area 2, which is a rectangle. 1 was a rectangle. Area 3 is also going to be a rectangle. And area 4 is going to be that triangle. Got it? All right, so again, for a rectangle, length times width, length times width, length times width, length times width. Oh, no. See, you get sleepy. The last one's a triangle. It's 1/2 base times height. Yes. Math and sleep don't go well together. All right. So here we go. Area 1, 6 by 4, right? That one's pretty straightforward. 6 times 4 is 24. 24 what? Square centimeters. All right, so area 2 is going to be a little more tricky. This one I can see is 4 right there, but what about this one right here? Well, again, if I come all the way down right here, that part from there to there is 10 plus 6 more. Do you see that? 10 plus 6. 10 plus 6 is 16. So this one is going to be the 4 times 16, which I happen to know is 64 square centimeters. All right, what about this one right here? That top part there is 4. What about here? Well, from there to there is 3, right? From there to there is 3. And what did we just say the rest of this was? We said it was 16, right? But if you wanted to go 3 plus 10 plus 6, right? You could do it that way. So 3 plus 10 would be 13 plus 6 is 19, or 6 plus 10 plus 3, however you want to do it. It's 19. So that one right there is 3, right? It was, sorry, excuse me, not 3, my apologies. This one right here we're doing is 4 times, so the width here is 4, and the height we said was 19. All right, so 4 times 20 would be 80. So 4 times 19 is going to be 76. 76 centimeters squared, right? 4 times 19, 76. All right, and this last one, which these triangles have kind of been boogers. All right, so 1/2 the base. Again, the base and the height of a triangle are always perpendicular, right? All right, so here's my base. I'm going to call that 5. And the height. Okay, here we go. So let's see what we can do here. So if we look all the way across, all right, and now I'm going to go a little wider. If I go all the way across here, let's see if we can know that whole length, right? If we know that whole length, and then we know this part from here to here is 6, right? Let me just come up here. See where those cross right there? Right? Whoops, a little crooked. Let me try that again. Right? So I'm going to put a point right here. Actually, I'm going to put it in black. See that right there? Okay. We know between these two black points, it's 6, right? And then between these two black points, that's going to be the height of our triangle. So if we knew what it was all the way across, we'd be in good shape, wouldn't we? Okay, so from there to there is 6. We know from there to there is 3. What about from there to there? Hmm. Well, I know from there to there is 4, right? So that helps me. So, do you guys see what I'm saying? From there to there is 4. From there to there is 3. But what about this little piece in here? What do I know? What can I do here? What can I do here? Well, let's see. If I go from here to here, guys, I know this is getting really complicated. Do I know what those two pieces are together? Those two pieces right there. I do, don't I? That's 4 plus 4, right? Do you guys see that? 4 plus 4. And what's 4 plus 4, guys? 4 plus 4 is 8, right? And from there to there is 6. So all the way across there, all the way across there is 8. And from there to there is 6. So this little piece right here is 2. You might have guessed that because it looks like it goes about halfway, but you couldn't know that for sure. All right, so it's 2 plus 4 plus 3. 2 plus 4 plus 3. And what's 2 plus 4? 6, and 6 plus 3 is 9. So again, man, that can be tricky. Some of you, maybe it's not tricky. The way my brain works or the way my brain doesn't work makes that hard. All right, so 5 times, here we go, we found that finally, is 9, right? So we have half of 5 times 9. Well, 5 times 9 is 45, and half of 45 is 22.5. Again, guys, you are welcome to use calculators if you're going, how did you know that, Mr. Reeves? 5 times 9, because I'm just amazing that way. Times, now remember, for a half in the calculator, if you have a scientific calculator that does fractions, you can do the half like that, and you can get the answer that way. Notice, actually, my calculator gave it to me as a fraction. If I do 45 divided by 2, I do get 22.5. Remember, you can also use 0.5, and you get 22.5 as well. All right, so there we go. So then I get an answer of, oh, wait, that's not my answer. I have to add all those together. Oh, whew, I almost put that in as the answer. Would have got it wrong and had to start all over. All right, remember, we're finding the area of all of these together. So 24 plus 64 plus 76 plus 22.5. All right, here we go. 24 plus 64 plus 76 plus 22.5 is 186.5. All right, now we'll put that in 186.5 and correct. Awesome. All right, so I hope this was helpful. Again, our second in our series on finding the area of composite figures. The first one was only made up of rectangles. That was a little easier. This one we added in triangles, and we found out that finding those missing segments can be a challenge. It's kind of like a puzzle though, right? So I hope that if you can look at it that way as a puzzle, it won't be as bad. And in our next video, we're going to throw in some semicircles and quarter circles. Thanks for watching. I hope this is helpful, everybody. Bye.